electricity, I will like to ask a couple of questions. Amna, I will ask you, what is electricity? What do you know about electricity? Like, what exactly is it? And you people, I would prefer if you speak on your mics rather than writing it down, writing it on the chat. So, Mahin, what do you know about electricity?
A form of energy resulting from the movement of electric charge.
Okay, lovely. So electricity, as you just mentioned, when we talk about electricity, it is exactly as what you just said. It is a flow of charge. Now, exactly what is charge? We'll learn about that as well because that is also important. Now, what I think you have studied is that every metal that we have or anything around us contains these protons, electrons, neutrons. Okay. And the metallic structure is such that it has positive ions and it has loads of free electrons. Okay. So basically, when we provide energy to these electrons, which are basically charge carriers, they're carrying a charge, right? Negative, positive, whatever it could be. When they move, they create an electric field around it. Basically, that is exactly what produces this electric current that we call it. Okay. So, and we learn about exactly what do we mean by current, what do we mean by charge, what do we mean by voltage and potential difference as well. But in simple terms, when we talk about electricity, it is basically movement of charge carriers. In what we know is that in actual it is movement of electrons. Okay, so the electrons move, they create an electric field around themselves, which produces an electric current, which is electric force as well. Okay, now we know that electric charge, we know that there are positive and negative charges. In chemistry, you might have learned positive are called protons and negative ones are called electrons, right? And some basics that you are supposed to know, that opposite charges will attract, like charges will repel. So these are some of the basics. I don't want to spend too much time on this because I think everyone knows. Yes, what you should.
Sir,
Yeah,
we don't have a definition for electricity.
I will come to that. I'm coming to that
Okay.
step by step, Mahin. But they won't ask me the definition of electricity, but I'll still discuss that as well. Okay,
Yeah.
because to understand electricity, we must understand what is electric charge. Okay, so that's why we are starting off with electric charge and this whole charge and how do we uh, show how charge is present. We'll first go all over that and then go on to the electricity thing. Okay. Okay. So these are some of the basics you're supposed to know, that they will repel if they are like positive, positive repels, negative, negative repels, and positive, negative will attract. And similarly, electric charge will be measured in coulombs. All right. The symbol will be C. So how much how much basically charge is flowing, that will be called coulombs. We'll come to that later on. Okay. Now, this is something that they do ask you in your exams as well. This is a very common question. Basically, they ask you to demonstrate electrostatic charges. I'm pretty sure, and do let me know. Do you people like, especially during winters, you can see charge, like you feel a current when you touch something? Does it happen to? I think it happens to everyone, right? Yes, I'm pretty sure it does.
Yes.
Yeah, I'm pretty sure it does. And basically, what happens is it happens because there's a difference of charge. When you rub anything, basically it creates a difference of charge, and that difference of charge basically produces this electrostatic charges. Okay, so this is the first thing what we learn about electrostatic charges is. What do you mean by static, by the way? What do you mean by static? Static, it means not moving, right? So unlike in electric circuit where the charges are actually moving, when we talk about electrostatic charges, basically uh, do show it through, and it's given over here. We show this electrostatic charge by friction. So basically, if we rub any surface, it produces a difference in charges. All right. And it can be done on an insulator. Obviously, it can happen to you with any object a piece of cloth, it could be a comb, it could be anything that can have a charge on it. Okay, that is called an electrostatic charge. All right. How do we show that? Well, we rub it with anything, and we'll not write rub it. Yeah, you should note this down, Mahin, because they will ask you how can you demonstrate electrostatic charges. Okay, you can note it down in short form if you can. Okay, because these basics, when these charges are same, they repel each other. All right, and then you can write in very simple terms that we can show electrostatic charge by friction. Okay, just write it in very simple terms. And friction, basically, how do we do friction? Produce like show friction? We rub it. Okay, we rub any object, and basically that is what produces electrostatic charges. So what we do is, as it's written over there, when we rub an object, let me see if I have one. Well, this will not. I'm pretty sure that my wallet does not. But let's say if it's a piece of cloth, if I rub it, now what happens is the electrons are transferred to the other object. All right, and that is what produces the charge. So the other object becomes negatively charged. This insulator becomes positively charged, and that is what produces the electrostatic charges. But it comes back to its original position very quickly. Okay, this is what you will exactly show if they ask you. They might ask you to draw a rough diagram as well. All right. So you will have to explain exactly this when they ask you to demonstrate electrostatic charge. So you won't have to write using the cradle method, but you will explain it using this. So, excuse me, we are given the stand over here and an insulating material suspended. Okay. And then what we do is once it's suspended using a string, obviously you'll have to give all the little details, and this will be important for your ATP as well. Okay. They do ask you these kind of questions in your alternative to practical. So you will use a string to hang this insulating material, and then what you will do is you will rub one end of it only with a cloth. Okay, and when you rub one end of it with the, we will do that as well, Mahin. Yes, yes, obviously we'll do all the papers, don't worry. Okay, but I mean, I want you to note all of these things down, because when we come down to ATP, MCQs, and theory questions now, this will be important, because all of these little details you will have to remember them. Okay,
Excuse me,
so
sir.
Amna, you're asking something?
Yeah, sir, आप इसके notes share करेंगे?
I will share this PPT on the drive after the class.
Alright.
This whole PowerPoint, this presentation, I will share this on the drive so you can look at it anytime you want. Okay. And do remind me, mine, I have to upload for magnetism as well and the other topic as well. Okay. Anyways, where was I? Yeah. So what we do is this insulating material that is hanging over here. Let me see if I can. Yeah. So this insulating material that is hanging over here, basically we bring a piece of cloth and we rub it. Okay. So when we rub it, what happens is the electrons are now basically transferred to the cloth. Okay. So now basically this thing now becomes charged. Why does it become charged? Because electrons have been removed from it. All right. Or electrons are transferred to it. It could be either way around, doesn't make any difference. But when we rub it, basically a transfer of electrons happen. And when the transfer of electrons happen, now this rod could be positively charged, it could be negatively charged, depending in which way the electrons were transferred. So once you have done this, now you have to show that this rod has been charged. How do we do that? We take a uh, charge material, okay? And I'll just show it over here. Basically, we take a charge rod and bring it near, and we know what the charge rod is. Okay, so we know that this charge rod is positively charged. We'll know it beforehand. If we bring it near to this hanging rod, if it basically attracts, we will know that this rod is now negatively charged, and if it repels, we will know it was if this is negative, then it will repel. All right. And if it had a positive charge, it will obviously repel from the second rod. The second charge rod, when it says charge rod over here, it means it had a known charge on it. Okay. I think it was mentioned over here. How do I go back? Sorry. Yeah. Okay, have you people noted this down? Khizra, why have you joined so late? Not that late, but still a bit late, right? Welcome, Khizra. I hope you can hear me clearly. Okay. Khizra, try and join exactly at 4 o'clock or before that because, sometimes if you miss the first 10 minutes, then it gets a bit confusing. So try to be a bit more careful, okay? Okay. Electric field. So basically, as I mentioned, any charged object basically creates an electric field around it. If it's positive now, remember this, you'll have to make these electric fields in your exam as well. If it is positive, the direction will always be away from it, and if it's negative, it will be towards it. Okay, note it down and then we'll move on. Beta, once you have noted down, I would want you to just give me a thumbs up or just say yes, done, something like that. Okay, so I have an indication I can move on. Okay. Okay, now this is important. Uh, Basically, exactly like in magnetism, guys. Um, when we have to show the strength of this electric field, okay. So if the lines are closer together, that will mean that the electric field is strong. Mine, everything. I will show you the syllabus. I am covering everything over there as well. I'll just show you the syllabus. Okay, just give me 5 minutes, and then I will show you. Okay, I have covered everything in IGCSE as well because everything I matched the whole syllabus for O levels in IGCSE, and then basically I made this thing up because every single subtopic or topic was exactly the same. Okay, so if there was anything missing, I will definitely make sure that I make you go over it as well. I will make sure that you don't miss out on anything. So mine don't have to worry about it. Okay. Okay, lovely. So what you have to note over here is, and they do ask you, they give you in MCQs, and they ask you which one is the weakest or which one is the strongest. The first thing will be that you will have to make sure that the direction always away from positive and towards negative. That will be the first thing you will check. And the second thing you will check is if the lines are closer together, it means the field is strongest, and if the lines are further apart, then in that case the electric field will be weaker. Okay, so it has come up in an MCQ. That's why I'm mentioning right now. Okay, they do ask you for which of these has the strongest or the weakest charge. What two things you will keep in mind? The first thing is that the direction should be pointing away from positive and towards negative. So that is the first thing that will give you an indication what the answer is. And then finally, you will check for the difference between the lines. If the lines are close together, strong field. If the lines are further away, weaker field. All right. Okay. Okay. So, like we did with magnetism, we also draw these electric field patterns. Electric field patterns, one thing is very clear that it will move from positive towards negative, even though everyone now knows that it goes from negative to positive. But because 100 years ago, 120 years ago, maybe people used to believe it was going from positive to negative. So that tradition has carried on. But in your exams you will make it from positive to negative. Okay, again, these are something which is this is something which is repeating. If the charges are opposite, they will be attracted towards each other, and if they're opposite, same, they will be repelled. Okay, So that, I think this is something you have noted down as well already. I'll just move forward. Okay. So field lines around a point charge, I just made you note down this as well. So I think we can move forward from this. Uh, that it goes away from positive and towards negative. You have noted this down as well. Yeah, if you have two conducting plates, you will always show a straight line from positive to negative parallel lines. Okay. So this point over here that is mentioned, make sure that you are very careful about this point and this point, directed from positive to negative and parallel. There will be no curved or anything. There will be always be straight if there are two parallel plates. Okay. So field lines will be exactly horizontal. All right. Okay. Lovely. Next. Okay. Now this thing is something I would want, you might in your ATP on your theory question, they might ask you to make a rough diagram as well. But when they ask you to show charge around a conducting sphere, this is exactly what you will have to write. This is exactly what you will have to explain in your exam as well. So initially what happens is that the charges are evenly spread or symmetrical, positive, negative, they're all equal. Okay. So this is the first important point that you'll have to note, that on a sphere the charges are basically evenly distributed. Okay. All right. It is all obviously connected to this to the system. That is why current flows through it. One thing you will have to note about this whole vendor graph generator is that the charges are the same, so they will repel each other. Okay, but all the important details I will just show them to you in this slide. Where is it? कहाँ गई? अच्छा ये नहीं थी. Wait, just a moment. कहाँ है? Okay, I'm back. Yeah. Yeah, you just have to note these 3 points, okay, about a charged conducting sphere. These are the only 3 points that you're supposed to know. That the field lines around a charged conducting sphere are symmetrical, like they are with a point charge. Only that's there are 4 points, by the way, not three. Fine. And the reasons are because of that. The next three that is given over here, basically, this is explanation for the charges on a sphere being symmetrical, that the charges are evenly distributed. The charges are the same, so they will repel, and the surface is conducting, so it allows the charges to move around the sphere. Okay. First, second, third, fourth. These are the 4 points that you'll have to know about field lines around a charge conducting sphere. So if it's a sphere, because they're evenly distributed, if you can see these lines over here, these charges will move and they will be evenly distributed. So they will be pointing only in straight directions like this. Okay. So even if it's like a point charge, it's positive. They are going like this. So exactly like that, if it's a conducting sphere, if it's spherical in shape, it will be exactly the same. It will be pointing away from positive. All right. And you'll just have to know that all the charges are will be evenly distributed. Okay. I will go over this very quickly because we know what are conductors. But if they ask you, we know conductors basically allow electricity to move past, or allow what is to pass, heat to pass as well. Insulator are those things that do not allow electricity or do not allow heat to pass through easily. It does pass, but in very small quantities, negligible quantities. Okay. So uh but when they ask you for the difference, this is what I would want you people to write. This is the definition. All right. And This is the definition when they ask you in your CI exam. Whatever I say, that is fine, but I have noted this down over here because this is what they expect you to write. Conductors will allow charge carriers to move. Insulators do not allow. That's why insulators do not conduct electricity. Okay. And in actual, insulators do not have free electrons as well. Once you are done, let me know. Okay. Now, uh, from your, I think in chemistry, you might have learned, right? That basically metals are, when we talk about the structure of a metal, it has positive ions in a sea of electrons. So basically, when we talk about a conductor, metals are good conductors. They allow charge to flow through it easily, and it is actually as it is written over here, usually electrons, because it has free electrons. Okay, so when you provide energy to those electrons, then they start to move. So when they start to move, basically that is allowing electricity to pass as well. All right. And these examples, silver, copper, aluminum, steel, this is what we normally use in our homes as well. We have copper wires, we have aluminum, we have steel, we have all of these, and these are all examples of metals. Okay. Okay. This is again something we know, that when we talk about conductivity, rubber, glass, air, water, they are bad conductors, or we say good insulators. Similarly, copper, iron. But you know what is important over here? What is important? Knowing this, that carbon is a much better conductor than water, air, glass, or rubber. So they might ask you, to list them down in order of conductivity. So this is something you should know, that carbon is a better conductor than water, which is better than air, which is better than glass, which is better than rubber. So they might ask you to put them down in order of conductivity or in order of insulation. Okay. Khiza, you are clear so far? Yeah, yeah. Mine, I'm waiting for you people to note this down. Okay. Khiza, I hope you're noting it down as well, right? Okay. Done, I hope. Okay. So moving forward, we know metals conduct electricity well because it has free electrons and current is a flow of charged particles. So we can move forward from this. And this is the structure of a metal, right? It has positive ions in a sea of electrons. All right. Electrons are yeah. Okay. Again, what happened? Why have it disconnected? We're disconnected? Yeah. Sorry. You still can't hear me, Mahi? Maybe my internet has. Khiza, you also can't hear? Okay, sorry. Apologies. कहाँ थे हम? Yeah. Coming back over here. अरे क्यों डिस्कनेक्ट हो रहा है ये? Okay, let me just wait. Okay. So what I wanted you people to notice that electrons are delocalized. That this is something I will want you people to note down, that in metals electrons are delocalized. Actually, that means they're free to move throughout the whole structure. Okay, they're not fixed in their position, they're not localized, they're delocalized, they can move anywhere. And that's why this flow of electrons basically produces charge or electricity. Lovely. Okay, done. So now this gold leaf electroscope is part of both your O level and IGCSE as well. So I would want you people to note this down very clearly, everything that's given over here. Basically, this gold leaf electroscope is used to distinguish between conductors and insulators. All right. And how is it exactly used? I will show that to you in a moment. But guys, I have one request from both of you. Uh, Kagya, I'll just pause this for a moment. What you have, what you showed through this gold leaf electroscope is, I think you noted down that it shows the difference between a conductor and an insulator, right? So I hope you people have noted this down as well. Let's quickly discuss this. I'm pretty sure you know that gold is basically a conductor, right? Gold will conduct. Okay, so um, if you have noted this down, look what we have over here is we have this gold leaf over here, and you might have noticed down over here that what happens is that when we charge the plate, okay, when we charge the plate at the top of this gold leaf electroscope, if they have the same charge, basically if the rod and the leaf have the same charge, they will repel. All right. And when basically the rod is discharged, basically the leaf will hang down. Why will it hang down, by the way? Mahin, it says when the rod and leaf are discharged, I'll just show it to you over here. This rod over here, right, and this leaf are discharged, basically the leaf will hang down. Why will it hang down? Basically, there's no attraction or repulsion, right? That's all you have to say. Because they're neutral, right? Oh, thank you. You're already turned it down. Very nice. So basically, there's no charge, there's no attraction, there's no repulsion, so it just hangs down. And if they repel, the leaf sticks out to one side. So that is how, if they ask you to show the difference between a conductor and an insulator, this is what you will write down. Okay. Okay. Now the next thing I'm about to discuss, I will not go into the details of anything else. But before I carry on with anything, I would want to know one thing. You people have heard of what a cell is, what a battery is. Can okay, you have to write this down. Yeah, note this down. Because I will ask you, what do you understand by, like, what is the purpose of a battery or a cell? What does it actually do? Do you know that? Just a moment. Yeah. Because what's the purpose basically of a battery or a cell? Shidra, what do you think it is? What happens actually in a battery or a cell? Mine, do you know?
Um,
Shidra
current
first.
flows
Shidra, you
through a
first.
device. Like current flows through a device, and in short circuits.
You know, current doesn't flow through a battery or a cell. Actually, this is not what actually happens. Yes, mine, I would want you to tell what do you
Like in a bulb or a phone, current flows through. In
mine.
a bulb,
No, Khizra,
They
yeah, mine. What's your answer?
it stores chemical energy and convert it into electrical energy to like
Wow.
power the devices.
So, Khiza, this is what I would want you people to know, that in a battery or a cell, what actually happens is, and I'll show it to you hopefully in the next class. that let's say if I take a cell and or a battery, anything, and I connect it to a wire and then connect it to the other end as well. Basically, what happens is that there is chemical energy in a battery. Okay, so uh, when we connect it to a wire, that chemical energy in a battery or a cell is it converts to electrical energy. How? Basically, that chemical energy is transferred to the electrons in your wire or whatever it is, and when they gain that energy, they start to move, which causes a current to flow. But that current will only flow if our circuit is complete, and we are coming to that point now, that when we talk about a complete circuit, incomplete circuit, what exactly it is. uh Quick definition in the chat by both of you. What do you know exactly about potential difference? And I want to know, I want you to write down very simple terms, okay? What do you think exactly means by potential difference if you have done it? If you haven't, that's fine. We'll discuss it anyways. I didn't. What didn't? Okay, okay, got it. Sorry. Okay, I have your answers. Exactly, Mahin. You know what happens is, when we say that the battery has finished, basically what happens is that that stored chemical energy is finished now. It has been used up. So there's nothing that can provide energy for the electrons to move in the wires. Okay. Okay. So Khizar, let me now see if I can connect it. You're right. I will try and quickly explain, go through what this. I'll just share my screen on my iPad so I can write it down. And we will be discussing that in depth along with some. Okay, here's my whiteboard. Okay, I have a whiteboard now. Okay, so what couple of things that we learn in the next class. I hope you will know that this is the sign for a cell. All right, and what is this sign for? What is the sign for this? Like what does it represent?
Battery?
No, this represents a bulb. Okay, this represents a battery. I think you were mentioning talking about this. I'm pretty sure. But if this is only one, like, so we call it a cell. Okay, and a combination of many cells will make it a battery. Now, uh, in simple terms, when we talk about potential difference, that actually means, so the current comes up over here, right? And it has to pass through this bulb. Okay, so when it has to pass through this bulb, it actually needs energy, right? It needs energy to move from this point to this point, right? So over here it will have a different energy. It will over here it will have some different energy. That is what exactly potential difference is. Okay, if in simple terms I tell you, it will be how much energy is needed for electrons to go from point A to point B. That is what exactly potential difference is. Now if there is, and you'll understand it immediately if I say that this is very high resistance. Basically very high resistance means that the current will need a lot of energy to pass from point A to point B, right? And if it is low resistance, then in that case, current can easily pass through. So it will need less energy. So when we measure the voltage across this bulb, it will vary depending on how much resistance there is. And I will show that to you, inshallah, in the next class, that if I have lesser resistance, the voltage across it is lesser as well, because current doesn't need that much energy to pass through, right? But if something is very high resistance, so current, and take an example of this. Very simple example we use an example of a pipe. If I use a pipe like with this width, and if I use a pipe of this width, this pipe A, and let's say this is pipe B. From pipe A, water will need a lot of energy to pass through, right? But from pipe B, it can pass through easily because there is no resistance at all. It can easily pass through. So this is exactly what we talk about for in terms of current as well. And this is what exactly is represented by potential difference. And we will learn how to calculate it, measure it. How do we measure it exactly? Where do we measure it? But for now, what I want you to remember is that it will be the energy required from for like a charged particle to go from point A to point B, and depending on the resistance, how much resistance is there, that much energy will be used. Higher the resistance, higher energy will be needed, means higher voltage will be across it. And inshallah, in the next class, we will see this practically as well. All right, I will make a circuit in actual and hopefully show to you in camera as well, and show you the different voltages that appear across different resistors depending on their resistance. What I want from you people, what I want from you people before the next class is I want you to note this down: current, EMF, just in your notebooks or online as well. Search for this. No, better not right now. Mahi, not right now, because this is something we'll actually do. And then I'll be showing you proper circuits. At the moment, I was just giving you a brief review of what I plan to do the next class. So you people are mentally prepared. And obviously, I would want you people to go through current, EMF, which is electromotive force. Basically, electromotive force is the total energy it requires a point from go from across a cell. But again, I would want you to go through it as well. Okay. So EMF, potential difference, these three terms I would want you to uh, search for it on your own. And one last thing is I will show you to over here before this ends. Stop sharing. Okay, so there will be I will share this whole document with you as well. But before I share this document, where is it? The very important thing. Yeah. So this is something I will share with you. I would want to go over this because I will not ask you to memorize it, or I will not spend any time over it. You should know what represents a cell, a battery, a bulb, or a lamp. Like in this case, what is a thermistor, the symbols for each of these, right? A fixed resistor, a variable resistor. So I will share this with you. Just have a rough go through it quickly before the next class. When we are discussing questions in the next class, I will expect you people to at least know most of the symbols, not all of them, obviously, but as we do more questions, you will have memorized them anyhow. But definitely, I'm just sending this to you on WhatsApp. Just go through the symbols before the next class, and hopefully, when we go to the questions, you will not have any difficulties in understanding. Okay, so that's it for today. Thank you, Mahin and Khizra. I will see you on Thursday. Make sure you go through those little definitions that I mentioned on the board. Okay.